we are going to look at how you can compare different scenarios and how you can create different scenarios with different parameter sets using attribute overrides and geometry configurations.
The purpose of this exercise is to compare the results of two different scenarios. We're going to create some different scenarios with different traffic demands and signal timings, and then compare them. I've started off by opening the model for scenario management, which is in your tutorials folder. The model already has a scenario set up, some signal timings, and the traffic demand. First off, we're going to create a new traffic demand. We're going to copy the old one by dragging it on top of its folder and renaming it to be 120% and change the factor to be 120. We're then going to create a new scenario for this to go in. To make a fair test, we're going to copy the base scenario by again dragging it on top of the above folder. We're going to keep the result/replication seeds, and then remember to change the names on your scenario, experiment, and replication. So I'm going to do that now before I forget. And then we're going to change the traffic demand in the scenario to be our new traffic demand. Once that's done, select both replications and click Run Batch. It will then run one replication and then the next. Once you have run both simulations, you can now compare them. If you go to Data Analysis, Data Comparison, and select your references, you can choose to compare any of these following objects. You can compare all of these for the whole of the model or a subset using a grouping. For example, let's look at the density. Press compare. We can see numerically the difference and also in a graph. You'll also see that you get a view mode created, allowing you to see where the density has increased or decreased. If you want to understand more about the coloration, you can go to Window, Windows, Legend, and we can see that where the density has decreased, we have red. Where it has increased, we have green. We will now test what happens if we change the signal timings. As you remember, we have two different master control plans. And if we go to node 2040, we can change the view mode back to none so we can see the nodes. Go to the control plan priority and look at the priority tab. We have set signal timings with priority given to the tram lines in comparison to the base control plan, which has this section empty. So first off, create a third scenario copied from the base. Keep those replication seeds and change the names to say priority. You can press F2 to quickly change the name of an object. We then need to change the control plan to be the priority control plan and run this. Once those replications have run, we can compare them in the data comparison tool again. Remember to change your references at the top, as these will now have changed to priority and 120%. So we want base and priority. And this time we're going to look at the turn delay. Turn delay time. Press compare. And you'll see you'll have a different view mode, this time colouring in the turns. If we go to legend, we can see that the dark blue shows a reduction in delay time of more than 50 seconds. And we can see that for the priority turns for the tram, there has been a big reduction in delay time, as you would expect with the priority scheme. In this exercise, we're going to look at how we can create different parameter sets in different scenarios without having to create a new model file. To do this, we can create an object called an attributes override. Create one, go to project, new attributes override, and you'll have a menu like this where we can add in objects. Parameters for sections, nodes, turns, detectors, vehicle types, lane types, bus lines, and bus stops can be changed with an attributes override. In this exercise, we're going to look at sections 936 and 939. Just going to change the view mode to none so we can see things easily. And 939 is next to 936. What we'd like to do is create an attribute override to change the bus stop type and to add in a bus lane. To add in the bus stops, we click them using shift to select both, change the attribute to be stop type, which is what the attribute we'd like to change is. Click add, and we're then going to change them from bus bay to being a normal bus stop. To add in the bus lane, we're going to go to the lanes tab, select both sections, click add sections, and then lane 2 of each one we're going to put in reserved compulsory for public. Press OK. We then need to add this to a scenario. Now, attribute overrides are actually stored inside the experiment as they are different parameter sets. So we're going to copy the micro experiment base, saving those replication seeds, and change those names. Attribute override in the experiment tab, we're also going to tick our new attribute override, so it will be called when the replication is called. Run your new replication. Once it's run, we can then compare the results again in the data comparison tool. Got base and attribute override, and we're going to look at the density. Press compare, and we can see that actually there's very little difference according to the legend, which I'll just open up, in the results along these sections. And then finally, save this network under the name Final Scenario Management. This exercise, we will cover how to create revision files. These are files linked to a main model, which record the changes made to the model file. They can be used for model maintenance, separating scenarios, or to allow multiple people to work on a model at the same time. Bear in mind that when you are relating two networks, both of them have to store their data in the same database. And to compare scenarios in different networks, they have to refer to the same database too. Therefore, the first thing to do is to ensure the database is exported to a common database. We're just going to quickly simulate a replication, so there will be data in the database. Then to create a revision, go to Project, New Revision. it will tell you that the document has to be saved before creating the revision. So we're going to say save. If you want to save it as a different model file, then you can use save as. Choose your revision name, what the base document is. What we've done is create a new file that is linked to the original file. Now that we have two networks, there are several options for modifying them. We can modify the base network, and this automatically modifies the revision with the same modification as the base network. Or we can modify objects in the revision. This makes the revision file the only one with the modifications. When the network is saved, the modified objects change their state to revised. Any object marked as revised will not contain the changes made in the base network, if any. Once an object is revised, it can only be modified in the revision file. Once the revision has been created, we're going to delete the scenarios that refer to what was simulated previously in the base network. We're then going to create a new scenario, call it revision, and we're going to go into the outputs to generate and check that that database is the same as we had before. Then save your revision, close the file, then reopen your revision file. You'll see it's now got an R in the menu. And if we go to the project, you'll see in external scenarios we have an experiment that we ran to save in the same database. This allows you to retrieve information from the base model and compare it directly with this model without having to actually have all of the base model information within the revision. In the revision file, we're now going to modify the network geometry to transform the signalized intersection into a roundabout. So we're going to go to the intersection down here, and we're going to delete the node. We're then going to select all of the sections, get the roundabout tool, drag it out, making sure that the red line intersects with the sections, and we'll see our roundabout will have been generated. We're going to change that to be 2 lanes, and that one to be 2 lanes, and we're going to run the revision. So just need to add in an experiment and a replication. Make sure you've got some traffic demand and a control plan. Don't forget to add in that public transport plan. Again, run the model, and you'll see in the log that a couple of the public transport lines have been broken because of the roundabout. We need to go through these and fix them. Change the view mode to be none. And you'll see there is a gap here in the drawings. So go through each one of the lines and add those in. When you press OK, it will also check if it's connected again, and we can see that it is. Carry that out for each of the bus lines. Once you've done that, rerun the replication to check for errors, and you should see that there are no errors for the PT line, and there aren't any. Now we can save the revision, and if we open up our sections, you'll now see that the new sections say revised. As in this case we decided to delete the node and remake it, we should detach this revision from the base, which means it will become independent. However, due to the fact we imported those external scenarios in, you will still be able to compare the base scenarios to our roundabout scenario. Alternatively, if you wish to keep the same model file, we can use a geometry configuration. In this exercise, we will use a geometry configuration which will allow us to create a scenario with different network geometries within the same model file. First off, let's open the network final scenario management. We're going to change the junction at node 1987 and this adjoining one 1983 to be a roundabout. To do this, first we're going to create a layer and make it level 0 and call it polygon. We're then going to draw a polygon after we've activated this layer to show where the junction changes are going to be. So draw around your junction and then cut each of the sections where your polygon intersects with it. Using a polygon helps you keep track of which sections are different and which are the same. Then it can be useful to select all of those sections that are inside the polygon, including the nodes and turns, and copy and paste them. This will mean that we have the exact parameters and geometry of the sections. We're now going to create a geometry configuration by going to Infrastructure, New, Geometry Configuration. We're going to go to the Non-Existent Here tab and select all of the sections inside our polygon. This means that when the geometry configuration is initiated, none of these sections will exist. And then press OK. To help us when we're creating the geometry configuration, we're going to assign this to a scenario so then we can see the network out these sections. So copy your base scenario, call it geom_config, and select your new geometry configuration. Don't forget to change the names of the experiments and replications. If we then go up to the top left and choose our scenario as a geometry configuration, you'll see that the sections will disappear. We can now draw in a roundabout instead of the intersection. To help us do this, I'm going to move the copied sections back, delete these nodes, and I'm going to move our sections around. Now it might be the case that as part of your scheme you also need to change the parameters of these sections, so you should also bear that in mind. So for now I'm just doing it very simply. I'm then going to select my sections, get the roundabout tool and create a roundabout. I'm going to turn off the OpenStreetMaps layer for now. We can see we've now changed it to a roundabout. Go back to the geometry configuration and add in the existent only tab all of the sections again inside that polygon. Don't forget to link up your old layout and new layout, taking care to not edit anything outside the polygon. We can then visualize the two layouts by going between the scenarios. Finally, we're going to run our replications so that we can compare them inside the data comparison tool. So go to the data comparison tool, select your replications, and we'll look at the count. If we press compare, you'll see that the area with the geometry configuration has come up differently. That is because obviously those sections can't be directly compared due to them only existing in one or the other scenario.